In earlier sessions, we have seen what is software architecture, what are the characteristics of the software architecture, that is, what the system should be capable of doing. And we have also discussed about software architectural patterns or styles, where we discussed about how we organize the system components, right? In today's session, we will see what are the components of the software system, right? When we say there is a system, what it is built upon, right? What are the components involved in that system, right? Logic, identifying the logical components of a software architecture is so important that it has its own name in the software architectural world. That is component-based thinking. Component-based thinking is seeing the structure of a system as a set of logical components, all of them interacting to perform certain business function. That is, we are grouping the modules or components of a system, and the components of the system interact with each other to perform a certain business function, to serve some business purpose, right? Let us take the example of a house. Okay? When we say that we are designing a house, um, maybe this is our living area, this is our bedroom one, bedroom two, this is our kitchen, this is our bathroom, right? So, what are these living area, kitchen, bedroom, bathroom? These are all the logical components of a house, right? In the planning stage, these are all the logical components. When we actually build the system, these become physical components, right? So basically, these are all the components of a house. Same way, in the software architecture, the major functions a system performs represents the components of that system. Like the rooms of a house, each component performs a specific function, right? Room has a example, living room has a specific function to serve, right? It is a sitting area or hanging out. So it is serving some purpose, right? Okay. Now, let us understand this with example. Um, Here, say we have order placement, order validation. Here we may have order history, and we can have shipment. Mm, Maybe notifications. What else? We can have return, right? Order returns. Okay. So these are all the components of a system, right? Say maybe this is a food delivery application, right? These are all the components of that system. Order placement, validation, notification, okay, order history, shipment, order return. So each component says what it is doing. It takes care of the order placement. This takes care of the validation. Okay. This takes care of the notifications. Each component is serving a purpose here. Okay. So when it comes to the real enterprise example, how these are manifested, right? So now we have understood these are the components, right? When we bring this into a real enterprise system, these are manifested in terms of folder structures or directory structures that each um, each directory has the code to implement this functionality. Okay. Yeah. Maybe this is the folder structure, example folder structure we have. Okay. The root is order. Okay. Now this is my root folder. Here I have ordering. Inside ordering, I have placement, that is order placement, validation, history. Okay, I'll skip the others. Then we have processing. Inside processing, we have fulfillment and shipment. Okay. So each leaf node of this directory structure has a functionality, right? This is a payment processing. All the code related for this payment processing is placed inside this directory. All the validation related uh, code implementation is grouped under validation directory, right? Same wise history, fulfillment, and shipment, right? So for what we have seen is the components are the building blocks of the software system, right? So what defines the software system? What a software system consists of, right? So now each component serves a purpose, business function, right? It has, so this model is doing this. This particular model or component is handling this type of functionality. Okay. Now, then we have understood how they are manifested in the real enterprise example. Right? We segregate them into folders. Each folder contains the code to implement that particular functionality. Okay. Now, there are two types of software architecture. Okay. When we categorize based on the components, that is logical software architecture and physical software architecture. So, what is logical software architecture? It is grouping the components, okay, component A, B, C, and defining how they interact with each other. This is the logical grouping of the system, right? What is physical software architecture is now we have all grouped them, right? They are we have designed and decided what goes where. Now, how do we organize them? organize them. That defines the physical software architecture. So when we say that we are organizing them, so what it leads to, that is architectural patterns, right? The way we uh, the the way we organize all our software components, whether I'm going to put A, B, C in a single um, system, right? These are all grouped together, right? Then this is monolithic architecture, right? If if I am separating, for example, A deals with user interface, B deals with business logic, and C deals with database, right? User interface, this is business logic, and C deals with database. When I separate them, this becomes the layered architecture. Okay, so this is how we identify the components, right? And identify how they interact with each other. Then we organize them into groups, those components into groups. Okay? There we lead to architectural patterns. This is how we evolve into understanding software architecture step by step. Okay. In upcoming sessions, we'll go deep into all these topics, understand one by one um, with example, with real enterprise example, all the patterns of the architecture and what are the components of a real enterprise system, right? Now we have just understood it one example. We'll understand more such examples. Okay. Yeah. Thank you for your valuable time.